Your brain prioritizes the pursuit of a goal over the actual reward itself. This chemical drive is not about the feeling of pleasure, but the relentless anticipation of a potential future payoff that keeps you moving. Inside your midbrain, clusters of neurons in the ventral tegmental area act as a master switchboard. They fire electrical signals that flood your system with dopamine whenever a survival or luxury reward seems likely. These signals travel directly to the nucleus accumbens, which serves as the primary reward processing center. This region translates dopamine levels into the physical sensation of motivation, urging you to take immediate action. The most powerful dopamine releases occur during unexpected rewards. This is known as reward prediction error. When a result is better than expected, dopamine spikes. If the result is exactly as predicted, the signal remains flat.
Conversely, when you expect a reward and it fails to materialize, dopamine levels drop significantly below your baseline. This negative prediction error causes the physiological sensation of disappointment and frustration, signaling your brain to update its internal maps. Dopamine operates on two levels. Tonic dopamine is the constant, low level circulating in your system that determines your overall energy and mood. Phasic dopamine consists of rapid bursts triggered by specific events or cues in your environment. The brain maintains a delicate balance between pleasure and pain. Every phasic spike is followed by an equal and opposite dip below the baseline. This homeostatic response ensures that you do not remain in a state of permanent euphoria.
Neuroscience distinguishes between wanting and liking. Dopamine mediates incentive salience, which is the urge to pursue. A separate system involving endogenous opioids manages the actual pleasure or liking of the experience once it is obtained. Frequent overstimulation causes the brain to reduce the number of active dopamine receptors to protect itself. This process, called downregulation, means you require increasingly intense stimuli to achieve the same level of motivation or interest. When receptors are downregulated, everyday activities lose their appeal. This state of low baseline dopamine is called anhedonia. It makes simple tasks feel exhausting because the chemical drive required to initiate action is physically absent from the synapse. Your prefrontal cortex acts as the executive brake on dopamine-driven impulses. This brain region evaluates the long-term consequences of an action, attempting to override the immediate cravings generated by the deeper, more ancient reward circuits.
Variable reward schedules are the most addictive. When rewards are unpredictable, the brain releases more dopamine than it would for a guaranteed prize. This explains the compulsive nature of gambling and social media notifications. Digital platforms exploit the novelty bias of the human brain. Each new post or video acts as a potential reward cue. This creates a loop of constant phasic spikes that prevent the baseline from ever fully recovering. Evolutionarily, dopamine evolved to encourage foraging and exploration. It rewarded our ancestors for finding new sources of food or water. Today, that same circuit is triggered by information, even if that information is irrelevant to survival. There are four major dopaminergic pathways. While the mesolimbic path handles reward, the nigrostriatal pathway controls motor function. This is why dopamine is essential not just for wanting to move, but for the physical ability to coordinate motion. The mesocortical pathway connects the midbrain to the prefrontal cortex. This specific route is responsible for cognitive control, working memory, and emotional regulation. It is the bridge between primitive desire and complex human planning. A severe lack of dopamine in the substantia nigra results in the physical rigidity seen in Parkinson's disease. This highlights that dopamine is the universal currency of movement, fueling both the mental will and the physical execution of action. The brain is hardwired to ignore repetitive stimuli. This is why a new purchase feels exciting for a week, but soon becomes part of the background. To the dopamine system, anything predictable is essentially invisible. When you focus on the reward at the end of a difficult task, you make the task itself more painful by comparison. However, by focusing on the friction of the effort itself, you can actually train your brain to release dopamine during the struggle. Dopamine levels directly influence your ability to maintain focus. In conditions like attention deficit hyperactivity disorder, lower tonic levels make it difficult to filter out irrelevant stimuli, as the brain constantly seeks a phasic spike to reach a functional baseline.
Physical stressors like cold exposure have been shown to increase tonic dopamine levels for several hours. This is not a sharp spike and crash, but a sustained elevation that enhances focus and mood without the subsequent dip associated with sugary foods or drugs.
Dopamine is suppressed by satiety hormones like leptin. Once you have consumed enough, your brain reduces the incentive salience of food. Overeating often stems from a breakdown in this communication, where the reward signal overrides the satiety signal. Social status is a powerful dopaminergic trigger. Gains in perceived status or positive social feedback result in significant spikes. This ancient mechanism ensures that humans remain sensitive to their position within a tribe, as status once dictated survival odds. Periods of scarcity or fasting can resensitize dopamine receptors. By temporarily removing high-intensity stimuli, you allow the brain to restore its receptor density, making everyday rewards like a simple meal or a walk feel significantly more satisfying again. Dopamine is released in response to cues that predict a reward, not just the reward itself. For an addict, seeing a specific environment or object associated with their habit triggers a massive spike, creating an almost irresistible urge to consume. Dopamine levels naturally peak shortly after waking and decline throughout the day. This rhythm is tied to your circadian clock. Exposure to bright light in the morning reinforces this peak, helping to set your motivation levels for the following 16 hours. Dopamine is essential for neuroplasticity. It marks which neuroconnections were successful in achieving a goal, strengthening those synapses. This is how habits are formed. The brain literally rewires itself to make rewarding actions easier to repeat in the future. The brain processes pain and pleasure in overlapping regions. High-intensity pleasure can actually heighten your sensitivity to pain shortly after. This is why the crash after a major achievement can often feel physically uncomfortable or emotionally draining. Intrinsic motivation occurs when the activity itself triggers dopamine release, rather than an external prize. This state is more sustainable because it avoids the downward pressure of the reward prediction error that occurs when an external prize is finally won. Flow states are characterized by a precise balance of dopamine, norepinephrine, and serotonin. This chemical cocktail allows for deep immersion in a task where the challenge perfectly matches your skill level, leading to maximum cognitive efficiency and temporal distortion. Dopamine antagonists are drugs that bind to receptors without activating them, effectively blocking the signal. These are used to treat conditions like schizophrenia, where overactive dopamine pathways lead to hallucinations, demonstrating how this molecule also shapes our perception of reality. Dopamine is synthesized from the amino acid tyrosine, which is found in protein-rich foods. Your body converts tyrosine into L-dopa and then into dopamine. Without these basic building blocks, the brain cannot maintain its necessary tonic levels. The brain uses dopamine to decide which synapses to keep and which to prune. During adolescence, this system undergoes massive changes, which is why teenagers are often more prone to risk-taking, as their reward circuits are highly sensitized and rapidly rewiring. Our modern environment provides a supernormal stimulus that our ancestors never encountered. Concentrated sugar, high-speed internet, and synthetic drugs provide dopamine spikes that are orders of magnitude higher than anything found in nature, leading to rapid system fatigue. While dopamine detoxing is a popular term, you cannot actually remove dopamine from your brain. The goal of such practices is actually to reduce the frequency of phasic spikes to allow your receptors to recover their natural sensitivity levels. Dopamine and serotonin often act as opposites. While dopamine is about seeking and more, serotonin is about satisfaction and being content with what you have. A healthy psychological state requires a dynamic interplay between these two powerful chemical systems. Excessive choices can paralyze the dopamine system. When faced with too many options, the brain struggles to calculate the potential reward for each, leading to a drop in motivation. This is why simplicity often leads to higher action rates. Long-term potentiation is the biological basis of learning. By consistently rewarding a specific behavior, you create a neural highway that requires less and less energy to activate. Over time, the action becomes reflexive, requiring almost no conscious dopamine drive. The brain often views your future self as a stranger. Dopamine favors immediate rewards over distant ones. Bridging this gap requires the prefrontal cortex to visualize the future in vivid detail, making the distant reward feel as real as a present one.
Dopamine is not your enemy. It is the currency of action and the engine of human progress. Understanding its mechanics allows you to move from being a passive recipient of chemical impulses to an active architect of your own motivation.